Good morning and welcome back to the Cloud Native Platforms track here in Spring One. We're really excited to bring you a talk this morning from Layla Porter on test-driven development and the Terminator, an introduction to test-driven development. And I got to say, I'm excited as heck to hear about this connection. To me, test-driven development is second most important thing in modern development after coffee-driven development. So that's totally cool. Layla is a developer advocate at VMware. We're really glad to have her on board. She's done a phenomenal job for us, and she's serving the .NET community. Huge background. She's a coder on Twitch, Microsoft MVP, a GitHub star, a director on the board of the .NET Foundation, and co-organizer of the MK.NET user group. And so Layla's here to share her knowledge, and she'd like you to know that no question is stupid and beginners are always welcome. I want to remind everybody that you can join the chat for this session. There is a way to find it if you look for session-tdd-terminator-test-driven-dev, but the easier way to do it is just go to the session page for this session and click on the join the discussion box there. And with that, without further ado, I'll turn it over to Layla. Layla, to you.
Hello, thank you very much, James, for that introduction. Hello, everybody. I hope you're having a good start to spring already. It's my first time here, and I'm very excited to be here and share some test-driven development with you. So I'm going to share my screen. And don't get scared now. I know there are some scary eyes there, but please don't get scared. So my talk today is on TDD and the Terminator, one of my favorite talks to give. It is an introduction to test-driven development. I won't linger on this because James has already done all the work there, so thank you very much. So you're probably here because you're wondering why on earth I'm talking about TDD and the Terminator. So I want to take you back to before I was an advocate, when I was actually an engineer, and this happened to be at a telecoms company. And we had millions of minutes going through our telecoms platform, and we only had 6 testers. That was it. And they were people, physical people. We didn't have a single unit test, not any tests at all. And we used to do releases, and it was after one such release that the testers did all their testing and came back with their regression bugs. And it took us 9 weeks to fix those regression bugs. A little bit of me died during that period, and I thought, well, there has to be a better way of going about software development. So I did some research, and I thought, actually, test-driven development would really suit the way I like to work. So I tried to go and do a little bit of it, and I found it really hard. I read books, I read blogs and tutorials, I watched Pluralsight videos and YouTube videos, and it just was not going in. I needed something simple that I could create and relate to. Terminator, all of them. I don't care what you say about all of them. They're all really good. I love them all. One of my favorite movies and sort of characters of all time. So I thought I'm going to program a killer robot because why not? So that's what I did. And my original TDD and the Terminator project is lurking around in my GitHub repo somewhere, but the one I'm going to show you today is a reincarnation of it. But first, let's have a look at some of the things that TDD does well. Some of these will apply for unit testing, so don't worry there. But let's go through some of the cool things about TDD. The first one I'd like to highlight is acceptance criteria. If you actually have clear requirements from your project owner, your issues, whoever is giving you the instructions, you can write the tests for it. And there's no ambiguity about what your code should do. And you get those ironed out right at the beginning before you write a line of actual code. So that's a great first start to it. Focus. If, like me and many other developers out there, you have a little bit of ADD, and a well-known phrase is shaving the yak. I'll put a link to that if you don't know what I'm talking about. It's at the end. But basically, to do X, you need to do Y, and to do Y, you need to do Z, and so on and so forth. And you never actually get to do the bit of code you set out to do. But with TDD, you actually are very focused. You just write code to pass your tests. Interfaces is the next thing. And I want you to think of these as a coding contract. Now you may think, what's that doing in there? Well, actually, it allows your colleagues to give you a coding contract, or you to give them a contract saying, this is the code I'm going to develop against. And they can get on with their code and you can get on with yours. And that allows for asynchronous development, because they're not waiting for you to finish that code, because you've given them a contract, this interface, that says, this is what I'm going to produce. You don't care about how I implement it. And that's really powerful. So what this also does is allow for cleaner code, because you're focused and you're only writing enough code to satisfy your tests and get them to pass. You're not getting bloat in your code. For example, you might think, oh, I'm going to just write this method because I know I'll use it later, and then you don't end up using it. But you don't get that when you do TDD, because you only write enough code to pass a test. Safe refactoring. Oh, how I wish I had safe refactoring back when I worked in that telecoms company. It would have saved me so much heartache. If we'd broken the code, our tests would have failed, and we would have known before it went to production, which leads on to fewer bugs, which is a win for everybody, because no one wants to do bug fixes. And the final thing, the penultimate thing I want to talk about is increasing returns. Because if you can safely refactor your code and you have fewer bugs, guess what? You can code features more often and more quickly. And you don't have to worry about going and fixing all the stuff that you just broke. It's a dream. It's definitely the dream. And all of your tests become living documentation, because you can use it as the basis for your actual documentation. I just want to note, it should not replace your documentation, but it's the starting point. And it's great for new team members to come in and have a look and see exactly what the code should be doing. So it's a great reason to have good tests. And some of those last few ones are obviously applicable to unit testing as well. But we probably want to get back to the Terminator. And we're going to start about the process of how we go about doing this, and starting with our TDD approach. Now, we need to gather the requirements. I'm going to play a video now. It has the slightest bit of flashing, and not really flashing, but I'm just warning you now, if you're sensitive, avert your eyes. So let's have a look. Oh, there's a bit of music. I wasn't expecting some sound, but let's go on. Because what we can identify from that is that we were looking at a boy on a bike and we needed to identify him. So those are our Terminator requirements. First one is scan subjects and determine if they require further investigation, and investigate subjects of interest and determine if they are the target, and if they are, terminate. Very important. But we are going to focus on this first one, scan subjects and determine if they require further investigation. So we don't want to go investigating everyone we see. We just want potential suspects. So I advocate for starting with failing tests. It's really important. And when you write tests after coding, you may be writing them to fit your code and not your requirements. Let me give you an example. You write code that returns an HTTP status code 200. You then go and write your tests that say, this should return a 200. Tests pass. Bob's your uncle, everything's fantastic. But the requirements actually wanted a 204, no content. So you've written tests to fit your code, not your requirements. So that's why it's good to write your tests before you write any code. I like to use the red-green refactor pattern. I'm going to show you that in a moment. But you start by writing a failing test. That's the red bit. You write just enough code to get it to pass. That's the key. Just enough code to get it to pass. And then refactor. So that's red-green refactor. All right, let's go and see this all in action. Now over here, I have a simple application. This is in .NET 5. I recently updated it. And my colleague Clara has given me some interfaces, those coding contracts. So let's see what we've got. We have an iSubject interface, which has a property subject name, which is a string. I have an implementation of that called subject. You can see here, it's implementing iSubject. And then this is the important bit that she's given me. She's already using this, and this is iSubject Analyzer. So this is the thing we're going to use to see if we should investigate a subject further. And we've got this one method here, which returns a bool. Should we or should we not investigate further? And it takes a subject. Now over here, I have my test class. I've called it Subject Analyzer Tests. I'm using NUnit. You could use XUnit or the test framework of your choice. I happen to really like NUnit. And you can see here, I've taken that iSubject Analyzer and I've created a private instance or an instance of it called SUT. Now that stands for subject under test. If you've got a lot of classes in here, dependencies to your class that you're testing, it could get confusing as to what you're actually testing. So I recommend calling it SUT. Now, most of the frameworks will allow you to do some setup. Let me just get rid of that little helpful bar. And what we can do here is actually go and instantiate our subject analyzer. But we can't instantiate an interface. So we're going to have to go and do subject analyzer. Now Ryder wants to be helpful and go ahead and do that. But that's the first stage. We haven't even written our implementation yet. So I'm going to go and add this now. So we're going to add a new class, call it subject analyzer. And let me zoom in. Now we need this to implement iSubject Analyzer, and then we actually need to implement the actual interface. So you can see that's brought in that bool investigate further. Now you'll see that it says throw new system not implemented exception. That's a great first start. We don't need to change anything else with this because we're now going to go and write our first test. So let's go back to subject analyzer tests, and we need to, I'm going to sneeze. I'm really trying hard not to sneeze right now. I'm sorry. So let's go over to write a public void. Now, there's several naming conventions you could use. I like to delimit into 3 sections. Some people will delimit each word. So I would go Terminator should underscore determine to, now we're going to see if they should investigate a woman further. Investigate woman further, in case it's Sarah Connor. And then coming down here. Now there's 3 things you need to think about. That's an arrange. Sorry, that's a, yes, that is it. An act, and then we have an assert. All tests should have those 3 things in mind. Now our act is going to be a var result, and we are going to do SUT dot, and then we're going to test that investigate further method. You can see, always do that. There we go. You see we've got an error here because this is expecting a subject. So we're going to arrange that next is equal to a new subject. And we're going to do that subject name is equal to woman. Yes, I am building a killer robot based on strings. Don't do that. Please don't build killer robots like that. Now, I like to use fluent assertions when I do my tests. They're nice and readable, but you don't have to. So you'll see they are should, and we want this to be true because remember it returns that bool here. Okay, so let's run. We have this play button here, and this should be failing because we're doing that red-green refactor. And you can see, indeed, it has failed. So this next bit I'm going to show you was my aha moment, the huge thing that just made it all click. Now, remember, we want to write just enough code to get our test to pass. So we need this to pass because it's true. So I'm going to go in here. I'm going to delete this. And can you guess what I'm going to write? Oh my goodness. That's it. Let's go and test it. See if I've written just enough code to get my test to pass. Run. It has. See, that was my big aha moment. I was like, oh, that's it. That's how it works. Right, let's write another test. Let's see if we can test if we see a boy. It should be true. So we can do a test case. Most frameworks will do this. Let's change that to woman. Let's stack this. This is a nice little feature. Let's go boy. Now in here, I'm going to just take that woman out because we're not only going to do that. And that's a string, and we can pass it in as a variable. So we're going to say subject name. And now we can take that subject name and replace woman with it. And if I come and look in my test, let's see, let's run that, run all. We can see, oh, well, that's not right. Something I did was wrong because that's now like a code smell. I didn't do my test very well because that shouldn't be a return true. Let's go and see if we can fix that. If we go and do if woman, if subject dot subject name is equal to woman, and that should be like that. And otherwise, we're going to do return false. Oh, I know what I did. I didn't do my other one first. So let's come down here. I'm going to write another test that does that bit. I've just messed my code up. I've just broken a rule. Oh my God. Okay, let me go and comment those out. Here we go. Let's leave that as that and come back in here. And we're going to go public void. And now if we see a Terminator, we do not want to go and investigate. Cannot type today. There we go. Terminator should determine, yes, that's correct, not to investigate further. Okay, so now we come in here and we go, we'll copy the insides of this. It's very quick. And we'll readapt that. That now is going to be a T1000. And because they're on the same side as us, and we want that to be false. So now, if we go and run all of our tests, let me go and run that one. I'm hoping that that should fail. It has. So now if we come here and do this bit, imagine I did it in that order and I didn't cheat. See how easy it is to cheat? But don't be so hard on yourself. I advocate for being pragmatic, not dogmatic when you start. Now you can see that everything has passed and we can start to build on that, but not today. So let's go back to the slides. So if I was going to refactor that, I'd have a big old switch statement, which is horrible. If statements, and then I'd make it into a switch statement. I'd do more with it, but I'm not going to show you that today. That's for another day. And you can see I can stack loads of cases on there. I can actually add more variables. I can put a bool in here and show that which it should return. And I can bring this bottom determine not to investigate further into the top one. So with good code practices, code management becomes infinitely easier. So let's see where TDD failures might happen. Understanding the learning curve, underestimating the learning curve. It is a steep learning curve. Trying to figure out how to go about doing this, it's really hard. You have to be kind to yourself. You have to find a way that works for you. Confusing TDD with unit testing. You see, I did it just then. How easy was that? I was like, oh, I'll just do this. And then I went back and did the unit test. And it's like, that wasn't TDD. So it's very easy to go and do that. Thinking TDD is enough testing. It's not. It really isn't. You need to do integration testing, user acceptance testing, people testing, all sorts. Not starting with failing tests. You see, that was an immediate code smell. I didn't have a failing test. I was like, oh, wait, what's going on? That's not right. And then not refactoring enough. That comes when you need to extract things out into other interfaces, especially if you're following some solid, and then not actually doing TDD at all. So that's where it fails, because you're doing one of those other things that I've listed. Now, implementing within your organization can be a little bit tricky. It can be controversial, and it is a significant cultural change. There may be resistance. Don't worry if there's resistance. It's normal. People don't like change. But give your developers enough time that they can go and pair program, that they can get on top of that learning curve, that they can work with each other, understand things, take the pressure off, explain to all the stakeholders that this is going to happen. So everybody is on the same page, because there will be an initial drop in productivity, and that can be really disconcerting for a highly productive team. You don't want them to feel like they're failing or falling behind. It is a big change, so allow for that and reassure. But once you've got that foundation, the culture has changed, productivity will go up and reworks will be reduced. And everyone's happy with that, because you can have an increased understanding of the requirements and their acceptance criteria. There's less of this, oh, well, actually, I meant it to do that. No, we did our TDD. We had everything worked out at the beginning. We got our acceptance criteria that we wrote our tests against. So there's none of that going back and reworking, because you already clarified it before work even began. And I mean, that is so very powerful. But basically, if you take one thing away from this very quick talk, I normally do this in 60 minutes. So if you do take one thing away from this, I want it to be that aha moment. If you're struggling and you're like, I don't know how to go about this, write a test and write the least amount of code you can to pass it. So remember this test here that we wrote right at the beginning, and then to get it to pass, all I did was return true. So that is the one thing I want you to take away. If you've been struggling with TDD, that's okay. It's all right. And then you go and refactor. Don't be afraid just to write that one little line, return true, and not worry about anything else. And just do that. So with that, I want to say thank you. Now, if you have more questions, I will be in a breakout room and in the Slack channel, at least for the next 15 minutes or so. So you can come in and have a chat with me. You can find me on Twitter at Layla Codes It. GitHub, you can find this project and many more on Layla-P. You can email me here at LaylaP@VMware. Now, the repo for these slides, it's my extended slides, is there at bit.ly/TDD-Terminator. That's the repo rather. And then there's a deck there as well. I stream regularly on Twitch twice a week on Tuesdays and Thursdays, live coding for hours, working and toiling on code. So you can come and join me and be part of the fun. And I'm on Twitch as Layla Codes It. And remember, I told you about shaving the yak right at the beginning. Well, you can go and read the story behind what shaving a yak means at that link there at the bottom of the stage. So with that, I'm going to say a huge thank you for joining me, and I will hopefully see you in Slack and on the Zoom channel. Thank you. Bye-bye.
Thank you so much, Layla. That was awesome. Thank you. Very, very fun presentation and much appreciated. As a reminder, Layla will be hanging out in the Slack channel, as she mentioned. Easiest way to get there is to go to the session page in the Spring One website and find that session page and click on the join the discussion link that is there. It can also be found directly in the Slack session with the name session-tdd-terminator-test-driven-dev. But it's much easier to go through the session page if you can. And we hope you enjoy the show. We will hopefully see you very soon. Thank you.